Hi, I am going to explain about Poisson distribution. Poisson distribution is used to find the probability with one condition. The condition is an experiment is having that is only two outcomes. Experiment should be. If consider and capital X is an experiment and it should be having only two outcomes. So then only we can use the Poisson distribution formula to calculate probability, to calculate average. It should be having only two outcomes. Then only we can go for that is Poisson distribution. And especially he is saying that if an experiment is repeated n number of times, infinite number of times, and in that case the probability to get success is very small, very less, then in that case we need to go for that is Poisson distribution form. This is the main condition. Coming to this here, I will explain here. You can see this. This is the Poisson distribution formula. P of x equal to x, that is required probability is e power minus lambda into lambda power x by x factorial. So I will explain here. Here lambda is a constant. Lambda is a constant. I will explain with example also. And that is equal n into p. N into p. Here this x is the required probability, either failure or success. So and lambda is a constant, that is n into p, and here n is number of times experiment repeated, and p is probability to get required, either success or failure. I am assuming here the probability to get success, to get success. So this is the case. I will take one example with the help of Poisson distribution. We can find the probability. So here consider an experiment, or else in a factory 20% of bolts are found to be 20% of bolts are found to be defective probability, found to be defective. So means defective probability is given that is 0.2. 20 by 100 means 0.2. And if 10 bolts are selected at random, 10 bolts are selected at random, or selected at random, then what is the probability? Then what is the probability? What is the probability? Probability to get two bolts will be defective. Two bolts will be defective. This is the question by using Poisson distribution. Will be defective. Two bolts will be defective probability. This is the case. Therefore, 20% bolts are defective probability. Means here P is equal 20% means that is 0.2. P equal 0.2. And according to Poisson distribution, and here in the above problem, n is number of bolts are 10, and he is asking x equal to 2. X equal to 2. Then according to Poisson distribution, therefore P of x equal to x, P of x equal to x is equal e power minus lambda into lambda power x by x factorial. So he is asking the probability for 2 bolts will be defective. X equal to 2 value is asking out of 10 bolts. E value is exponential value, that is 2.71, that is constant. Lambda is how much? Lambda is a constant, that is n into p. 10 volts out of the p value is 0.2, means it is 0.5. 2. This is 2. 10 into 0.2, that is equal, lambda is equal 2. Here you can say this in the right side corner. So therefore lambda value we found that is e power minus 2 into lambda power x, 2 power required probability also 2 by 2 factorial. So this is equal e power minus 2 into 2 square, that is 4 by 2. 2 to cancel, therefore final answer is 2 into e power minus 2. So this is approximately point, e value is 2.71. I said exponential value constant. So this will is equal to 2.7. 0.27. So means it is approximately 27% chance. Into 100 means 27% chance is there. And out of 10 volts, it is that 2 volts will be defective probability is by using binomial form. Sorry, by using Poisson distribution, we found that is 27% chance is there. Remaining, that is 73%. There is a to not get the defective bolts probability. Only 27% chance is there to get the defective bolts in that. So finally, what are the applications of Poisson distribution is, so we can find, by using this we can find defective elements in a factory. If you go for any factory, or else if you go for a mobile company, if they are design 100 mobiles, what is the defective probability while designing? So we can found that by using defective elements in any factory. And many games of chance. If you toss if you toss a coin, that is 10 times. If you toss a coin, what is the probability to get minimum? That is exactly 2 heads. 2 heads means here x equal to 2 heads is asking if number of experiment is repeated in n times. So like this, many games of chance, many games of winning chance we can calculate, and the number of transmitted signals also we can calculate like this. So if, but condition is there, uh, it should be having only 2 outcomes and the probability to get success is very less. In that case only he is saying that, the Poisson is saying that we can use my formula in particular case. So that is the Poisson distribution. Approximately is given that e power minus lambda into lambda power x by x factorial. Here lambda is a constant, that is equal n into p. So any doubt you can send to me. So thank you.